Okay, now what happens if our dot product, what happens if the two vectors are not given to us with angles? What happens if it's in the unit vector format? So if you go through and put some unit vector hats on there for me, we got to talk about what happens when you multiply unit vectors together. So for example, what happens when you multiply or take the dot product of I times I dot j, and I dot k? Well, from our properties, a vector that's dotted with itself is its magnitude squared. Unit vector has a magnitude of 1, so it'll just be 1. What do we know about I and j, though? I is the x-axis, or your x component. J is the y component. Those two are perpendicular to each other, so that means that they'll have a value of 0. Similarly, I and k will have a value of 0. If we go through and do all the possible combinations here, okay, j dot j will be 1, j dot k will be 0, and then all that's left is k dot k. We have all the possibilities. So what happens in the vector is in that format above. Okay, so if we are taking the dot product of ux I plus uyj plus uzk, and we're going to take the dot product of I plus vyj plus vzk. When you do the dot product, it's just distributive law. So this is going to get a little bit messy to start with. We're going to distribute all of those together. So the uxi is going to be distributed in. So we end up with ux dot vx, and I dot I is just 1. So that term would stay like that. Plus ux dot vy, and it's being multiplied by I times j, which is 0, plus ux multiplied by vz, and I times k is going to be 0. All right, now moving on to the uy term, and we distribute it in. So we have really a trinomial multiplied by a trinomial. So the next one we'll get uy multiplied by vx multiplied by 0, because j times I is 0, or dot I is 0. uy multiplied by vy multiplied by j times j would be 1, plus uy dot vz dot 0, because j times k would be 0. Moving on, we're now down to the last one that we're going to distribute into the process. We get uz dot vx times 0, k times I, plus uz dot vy dot k times j would be 0, and the last one is uz dot vz dot k times k would be 1. So if we go through and eliminate all the terms being multiplied by 0, they fall out of the equation, and we find out that we are left with the x terms are multiplied together, plus the y terms are multiplied together, plus the z terms are multiplied together. So we just multiply the x terms together, y terms, z terms together, and that gives us u dot v. There we go. So we're just simply multiplying together the x and y terms and z terms in 3D case. So our summary: u dot v for the vector for the one that's given above. So I'm given a, b, and c just to simplify it a little bit, or show it in a different format if you had trouble with the last way I represented it. We would simply be multiplying our x components together. So we would have a multiplied by d, plus we would multiply our y terms together. So b multiplied by e, plus multiplying our z terms together, cf. And keep in mind, this is also equal to the magnitude of u, magnitude of v, cos theta. So very, very important to remember that these are all equal to each other. They're just in a different format. And it will come up again, and will come in handy as we work through the examples today. So here we are with some examples. So I need to put some vector notation in here, and some unit vector notation. So dot product. So again, all we're worried about, we're not doing a real world application yet. We are just worrying about being able to do dot product of vectors. So the first one, we want to find u dot v. So that will be equal to 3, 7 dot 4, negative 2, and it's in coordinate form. It will be a scalar value. It's just going to come out to be a number. So I'm going to show all steps here. So you take your x values, multiply them together, plus multiply your y values together. So 12 minus 14 equals negative 2. And that's it. No other steps. With it in 3D and in unit vector form, u dot v equals the 2i plus 3j minus 4k, put it in brackets, dotted with negative I plus 6j plus 2k. It's the same process. We don't have to worry about the ij and k's anymore. We're only worried about the coefficients. So 2 times negative 1 plus 3 times 6 plus negative 4 times 2. So it's just the coefficients. You're just multiplying the coefficients of ij and k together. Negative 2, 18 minus 8. So that gives me a value of 8. So there you go. So we're not worried about what this represents, what this means. All we're doing is going through and doing the process itself with these particular examples. So to determine the angle between the vectors. Determine the angle between the vectors. So in order to find the angle between the vectors, we need to use u dot v equals magnitude of u, magnitude of v, cos theta. We have to use the cos theta because that's the only thing that has an angle associated with it. So we need to do the u dot v. Now, on the left side, the u dot v, we're going to have to actually do what we just did in the previous example and solve that. But off to the side here in rough notes, I need to know magnitude of u. So I'm going to have to calculate that separately. So that's going to be 2 squared. Holy moly. Try that again. 2 squared plus 4 squared. So that would give me 4 and 16. So it's root 20. Magnitude of v, square root of negative 7 squared and 2 squared. So that's 49 and 4. So root 53. Now we have all the values we need. So root 20, root 53, cos theta. On this side, I'm going to have 2 times negative 7 plus 4 times 2, root 20, root 53, cos theta. So in the numerator, I'm going to have negative 14 plus 8. So I'm going to have negative 14 plus 8, negative 6, divided by square root of 20, square root of 53, equals cos theta. I'm looking for the angle between them. So I just need a little bit of room here. Move that down. So that means the angle theta would be cos inverse. And again, you don't have a calculator, so you're just leaving it in its raw form for me. That's it. Okay. Does it become any more complicated when you are doing 3 dimensions? And the answer is no. Just one extra step when you're doing the calculations. There's that k component now that you need to be concerned with. So again, u dot v is equal to magnitude of u, magnitude of v, cos theta. So 5, 2, and 1, dot with 10, negative 3, and 4 equals, down below here, I need to find the magnitude of u. So that would be the square root of 5 squared plus 2 squared plus 1 squared. So that's 25, 29, 30. Magnitude of v, 10 squared, negative 3 squared, and 4 squared. So that's 100, 116, 125. So now I have the square root of 30, square root of 125, cos theta. So theta will equal cos inverse. On top, I'm going to have 5 times 10, so that's 50. So I'm doing this in my head here. So 50, take away 6, 50 take away 6, 44, plus 4 is 48, over root 30 and root 25. And you can do an extra step in there, it doesn't matter. But that is the solution there. Again, you don't have a calculator, you can't take it any further. So there are your calculations. All right, and I'll leave, I believe, finish up the examples in the next segment. And we're almost finished. Yeah, just one more quick example.